Did we get our 5 summary numbers yet?
Yes.
What's your min?
19.
What's your max? What's your Q1?
27.
Median?
32.
Q2? 32? Q3? 28? No, 38?
40, 45.
40.5. Okay, now, those are our 5 summary numbers. That's all it takes to make us a box and whisker grid. So we're going to make a number line. We're going to call this our tuition cost because it's a graph, so we labeled it. These are in thousands, but it makes it easy without all the zeros to it. We're going to make a number line, just like you do a dot plot, that goes from 19 to 46. So if we started it at 15, we can go every 5. Your box and whisker graph has to sit above your line. Take these 5 points and just dot them out. There's my 19. There's my 27. There's my 32. There's my 40.5. And here's my 46. Okay? Now, the middle 3, what was that?
You don't subtract. Oh, never mind.
No, don't subtract anything yet. Just give me, we're just making the box and whisker first. The middle 3 is the box. It has a box, and then these attach the whiskers. Now, we said yesterday that even though this doesn't look like it's even, it shouldn't have to be even, but each one of these little groups is 25% of your data. Each of these little groups represent 25% of your data. And here's 25, and here's 25, and here's 25, and here's 25. How could that be that this little piece is 25, and the big piece next to it is also 25% of your data? Huh. Good, because the range is smaller in that. Very good. There's these pieces right here. They're just more spread out. It still contains a quarter of our data. This guy still contains a quarter of our data, but like Hilda said, the range is smaller. The numbers are closer together. If we looked at them between 27 and 32, look how many the numbers are in here. Oh, they're not in order. Okay, we would have to put them in order from lowest to highest. We would see 27 to 32 has a lot of numbers in there, smallest range. Good, so we know what that represents. We also talked about finding any outliers. We said we can find the interquartile range. Anybody remember how we find the interquartile range, Angela?
Q3 minus Q1.
Good, Q3 minus Q1. It's within this piece. This actually is 50% of your data. 50% of your data lies there. Because 2 quarters make 50 cents, 50%. So Q3 is 40.5 minus Q1, which is 27. And that comes out to be what? 13.5? Huh? Yeah?
Yeah.
Okay, 13.5. All right, now, from that, we can take this and we can multiply Q1 and Q3 by 13, by your interquartile range, 13.5. Look, hang on, sorry. I mean, take this and multiply it by 1.5. This is like such a weird day. All right, 13.5 times 1.5 is what?
In the calculator, Q1 is 26.5, so is it 27 just round up, or is it
Your Q1 is 26.5?
It is.
It is 27. Who gave you 27? 26.5. You gotta give me the exact ones. Thanks, Sally. 26.5. Okay, it kind of, my graph still looks the same.
Wait, mine says 27.
Well, then your data must be wrong because the book says 26.5 also. So check your data. Your min was 19 right here. Your max is 46. Your middle is 32, 40.5.
Do the rest of it.
The rest is good. Okay, so this becomes 14, right?
Yeah.
All right, now take 14, let's multiply it by 1.5. So this becomes 21, right? Now, we're going to take your quartile 1, and where can we find an outlier? To the left or to the right of quartile 1? To the left. So we're going to take quartile 1 and subtract 21. So your quartile 1 is 26.5, because we would find it to the left. Do we have a piece of data that is 5.5 or less? No. Our min was 19. Do we have anything less than 5.5? No. We have no outliers to the left. Where would you find an outlier? To the right or to the left of Q3? To the right. So aren't those numbers bigger? So we add Q3 plus 21. So we add 21 to this, and we get 61.5. Do we have a piece of data that's greater than 61.5? No. Our max was 46. So therefore, this data set has no outliers. And it makes sense that you would add to the right, because that's where you would find your outlier, subtract from the left, because that's where you would find your outlier. The middle 50 is fine. The middle 50% is contained in the middle. So this is what we looked at yesterday. Taking our numbers, putting it in L1, making your 5 summary numbers, making a box Whisper graph. Don't forget to give it a title because it is a graph. Find your interquartile range, subtract it from quartile 1, add it to quartile 3. Carson?
How do you get 1.5?
1.5, it's in the formula. There is a little formula that I gave you on your notes, and it is right here. It's a little formula that they use to determine if we have an outlier. You're going to take your interquartile range after you find it, and you're going to multiply it by 1.5. Okay? So it makes sense that we subtract from quartile 1, that we add it to quartile 3.
If you have like more than one of the same numbers, you
Wait, more than one of the same number? No, you're not plotting those points. This is not a dot plot. But your number line starts off looking like you did your dot plot. You need every number on that number line. All you're plotting is your 5 numbers. That's all I want, 5 summary numbers. But what I meant from that, Alex, that I probably was misleading, that number line is the same the way we started with your dot plot. We needed to cover every point that was there. So we go from your min to your max on your number line. Same as we did with your dot plot. We started your min, we went to your max. Okay? Okay. Today, we're going to move along into, we did that. We're going to move along into your percentiles. Now, percentile in itself is just a ranking. You know what percentile, if you're standing in your class, you can guess what percentile, you're in the top 10 percentile, you're in the top 5 percentile. Doesn't mean your score was 5. It means you're in the top 5% of your class, right? If your class has 200 kids in it, and you're in the top 5, you're probably in the top 5%, you're in the top 10 of your kids, right? So it is just a percentile. You took these, when you're in elementary school, you took these PEP tests or Iowa tests or whatever they call them at the time, and they gave you like results like bars, and they said for your reading comprehension, you had 86 percentile. For your math comprehension, you had 94 percentile. it didn't mean you scored 94%, not 94. It didn't mean your score on that test was 94. It means you scored better than 94% of the kids that took that test. It was a percentile. It was a ranking. I don't know if they still give those in elementary school. I know they gave those when I was young. They give you a ranking on that, along with your score?
Yeah.
Oh, okay. Okay, so they'll give you some kind of a ranking and tell you how you stood in your class. As a matter of fact, your book references a percentile of FAQ scores.
Well, because they do that. They're like, you're in
They-
the top 90%.
90 percentile. And believe it or not, we're going to find with the percentile, that's what colleges look at. Colleges don't want to look at your individual scores. Colleges say, I want the top 10% of these kids. So they figure out what was the cutoff for the top 10%. And they take that. So already you're getting percentiles, so that is good. That probably is new to that. So this is one of your SAT percentile scores. And this is what colleges like to look at. They like to see where their kids sat on the percentiles.
So like, just talking about like SAT scores, if you were to take the score that you want, you would divide it like from
No. Your percentile is done like a frequency chart. It's kind of like, how are you ranked? That would mean everybody had an equal chance of getting every grade. Mostly what I think they start like at 200 or something, and they figure out like how many kids were in this range, how many kids were in that range. So we have a formula for percentile that I'll give you in 1 second. How many kids were lower than you, how many kids were higher than you. But you kind of figure it out that way. You don't figure it out on your basic score. Yeah. So here's like a good old jive, because it's an accumulative thing of percentiles from 0 to 100%. So if your score was in around 1800, you would come up here and you would find what percentile you were ranked at. Somebody at the 62 percentile, what was their score? We can figure out what their score was, about 1600.
Now, is it better to have a higher or a lower?
Better to have a higher percentile. That's your ranking. So, because of your guys are asking ahead of time, let's just flip down to this for a second. Maybe. Here's how they actually find your percentile ranking. To find your ranking number, they figure out how many, for instance, took the SAT test. So there's thousands of kids that took the SAT test. Your particular grade, your score, how many scored less than you over the total number of how many took the test times 100. That's your ranking. So like your class ranking, what would there say 300 kids?
It's 712. 712 kids.
712 kids in your class?
Now, that's only people that they have registered for senior. There's still repeaters and there's still
Oh, okay. So in total, as considered seniors,
Well, they're
712.
considering 712, yeah.
Holy smokes. So they want to know, like, say your grade point average right now is 99.2. How many kids scored less than you? So if there's like, out of 712, say 700 scored less than you, it's 700 over 712. And times 100 puts you in your percentile. That's how you figure out your percentile ranking. How many are less than you to do this? Times 100, that's what gives you your percentile, otherwise you just have a decimal. Wow, 712.
712
You would correct your rating on your transcript. So like,
Oh, that's how they do it? Okay, wow. Okay. So here's a good example. Here's a data set. And you have to have them ordered highest, lowest to highest. You have to be in order because you have to be able to see how many are below you. So you need them in order. Now, in this data set, these are tuition costs for colleges, and they're in thousands. We want to know what percentile would correspond to a college that has a $30,000 tuition cost. So we find 30,000. And we first say, how many are there? We count each one, 1, 2, 3, 4, 5, blah, blah, blah. There's 25. I know that because I counted before. And you count how many are less than you. 1, 2, 3, 4, 5, 6, 7, 8, 9. times 100. 100 just flips you to a percent. So that is ranked at the 36th percentile. It means it is more expensive than 36% of the colleges, less expensive than 64% of the colleges. Okay, that's the ranking. So like you're looking at a college, if cost is one of your criteria, do you want one that's ranked lower or higher? If cost is a criteria, lower. You want a lower ranked one, right? You want one in the lower numbers. If cost is not a criteria, then you don't really care about that. Maybe you looked at something else. But SAT scores are great for percentiles. Because colleges will automatically weed out, like, oh, I only want the top 10 percentile. When we discuss Z-scores, we figure out the exact score that they look at. Say, I don't want anybody less than this. They give us a percentile. We use area under your curve to do that. And we can figure out the exact cutoff. Because every year they don't want to go looking through the scores and say, well, this year my top 10% is at 2100. Oh, last year my top 10% was at 1950. They don't want to have to do that. Every year they just take a cutoff mark and we use a little formula in statistics and we give them their cutoff mark. But percentile ranking is something that's used quite a bit. If you're going to find the percentile that corresponds to the 26th percentile, now, when you do this, you have to consider 26. You're equal to this. Some consider it at the highest, some consider it at the lowest. But if you consider this, when you first hit the 26, you have 1, 2, 3, 4 below you. Times 100 puts you in your percentile ranking. And it doesn't mean that that 26 above you is any different. Like, remember with the cumulative graph, the OJI? It's probably easier to see on a cumulative because those 26s would be ranked together. They would have their frequencies together. But if we do this, what is this give us? 16%. You're at the 16th percentile. You are ranked about the 16th percentile. So percentiles are a nice way, without looking at your individual scores, to consider where they are. And again, they give you another chart. The charts are easy. If you take a look at, and I'll go back to these charts. They're nice to like find your percentiles off of this chart. SAT scores. This was your ages of the most powerful women. How you're ranked, how their ages are ranked, not with their particular ages, minus everybody else's age, but out of how many there were. So say I want to know the age of 70.5, I come over here, I follow it across, and I find its ranking. You can also rank on your normal curves. Here's your curve, and we're going to see this pretty soon. These are your positive ones, these are your negative ones. You know all your negative ones. You know all your percentiles that are in here, right? So in between here, there's 68, so this was like 34 percentile. Obviously up to here, you're 50%, right? Up to here, you add another 34. You're at the 84th percentile. You should have done this like in Algebra 2, looked at percentiles on your score charts. Because that's what a lot of your Z-score curves are used for, percentiles. If you start from the 0 on up, you just keep adding the percent. Like this was like at 0.1%, then you add a 0.5, then you add a 1.7, then you add a 13, whatever these percents are, 9.2, 9.67. From here to here, it's 100%. So if you read from the left, that's your percentile ranking. So if you look at your scores overall, and you figure out how far you are away from your standard deviations, these all tie in, because this is 100% of your curve. So percentiles aren't so bad to look at. What I wanted to get to today, does anybody have any